Hello everyone, Sabah this side, and welcome back to the Security Architects Playbook. This is the third episode, and yes, I'm still here trying to make complex architectures slightly less painful to understand. If you're trying to grow as a proper security architect, you're in the right place, and let's begin. So let's get into the topic today. This session is about assessing a API gateway plus microservices architecture, but from the actual brain of a security architect, not the random vendor brochure or like nine arrows, zero meanings, and all those things, right? Let's not go in that direction. So the goal is pretty simple here. I'll show you how a architect thinks. When I say architect, security architect, what we look at, why we care about that, and how to avoid the usual disasters. So that's our motive here. Moving on, here's the plan. We'll look at the architecture first thing, break down each layer, walk through the controls, and finally go through an assessment checklist that mimics a real engagement for you. And yes, we'll also talk about the solution architect versus security architect. There was some questions about this in the previous video as well. So moving on, let's start with the bigger picture here, right? So a user sits out somewhere here. It can be corporate devices, your BOEOD devices, maybe some automation scripts pretending to be humans. Their traffic hits the API gateway here, right? So this gateway is the bouncer. It checks who is allowed in, who is suspicious, who is carrying some nonsense, right? So then past that gateway, we've got a bunch of microservices. So these microservices communicate with each other as usual in every other architecture, sometimes sensibly, sometimes like a confused team meeting where everyone calls everyone for no reason, right? So it can communicate in that way as well. So at the bottom, we have the database, the queues, the storage buckets, and all these things. And finally, everything throws the logs into the monitoring layer because if you don't, you can figure out what exactly exploded in the middle of the night, right? And when it comes to this API gateway, what you see here, right? It is shown in the microservices layer purely from a deployment and runtime perspective, not as a business microservice, right? So conceptually, it functions as an edge and policy enforcement component, not part of the domain logic itself. So its placement in the diagram is just for simplicity. Its responsibility remains strictly infrastructure and control plane focused. And this is the entire mental map you'll hold during the complete assessment. Your brain must actually automate looking at every trust boundaries, the token hops, and the privilege crossing. Okay, now the entry points, where exactly the problem starts, right? So we have got human users, service accounts which will do some automation, the mission calling APIs, sometimes legacy systems that don't even believe that OAuth existed, right? And as a security architect, the mindset here is supposed to be you're not just asking who is the user, right? You're asking how does this identity earn that trust and what device it is coming from, and is the device security posture good or not, right? Also you're checking the OAuth OIDC token flows, whether that is implicit. If yes, please say a big no. Whether it is hybrid, maybe, because based on many considerations. If it is a PKCE, you can say yes. When I say PKCE, it's the proof key for code exchange. Yeah. And the client credentials for machine workloads only. So consider all these things. And identifying the flow correctness is one of the biggest failure points here, right? So you have to identify that properly. Moving on, the API gateway, the authentication layer this is, right? So when it comes to the API gateway, that is your choke point usually. So if this fails, the entire architecture collapses completely. So when accessing this point, right, when you go assess this from a security perspective, start with token validation. It must be enforced on the server side first thing. And if you have any JWT signature validations, that must happen locally, right? Then the token TTLs shouldn't be forever. There should be expiry time for that. And TLS must be mandatory and you cannot set that as optional. Make sure you look into all these things. And from a security architect mindset, you're basically thinking what? Can someone fake a token and just get in? That's one thing. And can someone replay a token which they loot, right? And is token introspection done correctly? These questions define the direction of the assessment usually. Then security controls on the API gateway side, right? So this is the API gateway security brain itself. You're looking for what? Input validation, your WAF policies, the rate limits, if in case you have abuse protection enabled, the RBAC, ABAC logic, all these things will be checked here, right? You're checking whether the gateway is the only enforcement point or if the organization is relying on microservices to repeat the same controls, right? Whether directly a user can reach out to that service. In that case, having a API gateway doesn't make sense. So you have to check that. And your job is to make sure the only thing passes through are clean, validated, and authenticated requests, not some random junk or any malicious payloads, right? So we need to make this as a security architect here. Okay, next comes the API gateway traffic control, right? So how traffic is handled actually defines whether the system survives any failures, right? So first thing to talk about the rate limits. Are they per user? Are they per client or per access token? This need to be checked. Then the allow deny side of it, right? Are IPs controlled? Are they using reputation based filtering? Check all these things. Then comes your circuit breaker logic. Do they prevent cascading microservices failures? Check this. From a architect mindset again, from assessment side point of view, what happens when a microservice is slow or when traffic spikes? This actually tell you whether they will survive an attack or just fold away. Then the microservices layer itself, right? So microservices, usually the name sound cute for me, but ideally it comes with very big problems, right? So from an assessment point of view, first thing, start with the service discovery and MTLS between the services, check that, the workload identity, secret management, network policies, internal API authentications. So ideally it's supposed to be zero trust internally, right? Because if one microservices is compromised, the attacker shouldn't instantly own the entire cluster. We spoke about this in the previous video, zero trust. You can go through that to check more about that. So what you actually check here in short is like, are secrets in environment variables? Usually they will be, so check that. Are secrets using mutual TLS? Are microservices allowed to talk to each other freely? Usually they shouldn't, right? So check that as well. Then comes your infrastructure layer. So infrastructure is the foundation where usually mistakes will be forever from a very long time. So starting with the DB isolation, separate schemas, least privilege accounts, no microservices should have the God mode access. Say I'm the admin, I'm the privileged user and all, right? Then the message queues mostly ignored by the teams. So check if queue access is authenticated, whether it is encrypted, and the permission is properly scoped. Check all these things. If you talk about the containers in your infrastructure layer, check the baseline hardening, check the runtime controls on your containers, check your image provenance as well. And what exactly you're thinking here is what happens when something in infra gets compromised? How far does the damage is going to travel? So that's the thing what we have to think from a security point of view. Then comes your monitoring and security layer, right? So we call it security because we wanted monitoring to be done just to make sure we go back, reverse track what happened and why it happened using the logs. So monitoring is where you ideally discover things before someone else tells you, right? So that's the reason. And when it comes to the assessment focus here, first thing, the API telemetry. I'll also think about the UEBA logs if there are any, the service logs, authentication failures, CI/CD integrity, and all these things. So just look for missing logs. If there are any useless logs or logs that exist but nobody reads, right? So try to streamline all these things in this particular layer. You have to check if this system is attacked. Can anyone detect it within minutes? Or will it be like quietly burning for 6, 7 months? This is what you have to check in this layer from a very high level. Then, as usual, we'll have a assessment checklist here. So this is just for your systematic process. So you walk through the entry points, OAuth, OIDC flows, API gateway config. the validation and WAF policies as well, the microservices trust boundaries. We spoke about this, right? So one microservice directly talking to the other one, so that's not supposed to happen. And how good the secrets are being handled. Then you talk about the DB, queue, storage, and the permissions for all this. Then the container baseline, the monitoring model, how many logs are there, whether it's useful or not, whether it got an incident process around that, all these things. Then your CI/CD hardening altogether, right? And again, most of this will be taught from a security architect as well as a solution architect perspective. But the difference here is solution architect think like how do we build it to work, right? When I say build it, build the architecture to work. Security architect think from a perspective where how do we build it so even if people behave like a maniac, the system won't collapse, right? So that's what a security architect will usually think about. So ideally, security architects we design for worst case, we think from failure path, right? So we make system resilient, not just functional. I have some friends who tell me saying like, why are you talking negative? I used to say because I'm a security architect. Always think what happens if it goes negative, right? And yeah, then comes your common gaps. Here's where the real world pain is, right? So most of the architectures what I have seen before, it used to be like no rate limiting, weak token validation, hard coded secrets everywhere, microservices overly trusting each other, missing logs or failed authentication, and you're not recording those failed authentication, and no single identity model. And believe me, 90% of companies have at least three of these in some of the architectures, right? So this is what makes assessment important. Otherwise, usually like problem remains invisible until they become some incidents. Now, a quick summary. So wrapping up, API gateway is your primary enforcement point. Microservices needs their own trust boundaries. Identity is your backbone. Observability is how you avoid the blind collapse, right? So if you think to be a security architect, and you're learning for that, start questioning the trust, start validating the boundaries, start imagining the failure path. You will access any architecture confidently. Thanks everyone for listening and see you in the next series. Thank you.